Yeah, the hyperbola, sure. I think it's also the Hurley symbol. Okay, fine. The general form of a hyperbola is x minus h over a squared, y minus k over b squared, the square of both of those, and then it's equal to 1. And here's the difference from the ellipse. Literally, pun intended. The hyperbola is the shape that is equidistant. The difference of the two lengths is equidistant from 2 points. Okay, those points are still called the foci. Let's get to an example. Yeah, here my a here. This is 2 squared. Okay, so I go over 1, 2 in the x, and I go over 1, 2 in the y. I see I'm at the center because there's no numbers in the associations with x and y. Here this is 1 squared, so I go up 1 and down 1. And here we're using the box method. I draw a box through those 4 points. And then what I do is I connect the diagonals of that box. Yeah, ready? Here they go. I'm running the diagonals through the corners of those boxes. Yes! This is going to give the end behavior of your hyperbolas. Now, the minus sign's on y, so it opens away from y. And your hyperbola is going to go, it's going to touch that. That's called the vertice. Bam! And out in both directions like that. But it also does it on this side. Bam! Like that. Okay, let's get down here. We got to get this in standard form. So I'm going to divide everything by 36, by 36, by 36. Why? Because the standard form of a hyperbola is equal to 1. And then here we will see this. So then this is x squared over 4 minus y squared over 9. And then that's equal to 1. Fun! Here, that's the square of 2. I'm in standard position, so I go left 2 and right 2. Ooh, that's the square of 3. So I'm going to go up 3 and down 3. Oh, then I'm going to make a box. Then I'm going to connect and extend the diagonals of that box. Then I find the sign is negative on the y, so it opens away from y. And it's going to look like this. Nice. Are we ever going to get an example where it opens the other way? Which brings me to my next example. Yeah, okay. Here, under y, I have 9. So I'm going to go up 3 and down 3. Okay. Under x, I have 25. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. And then I make a box. And I connect the diagonals of that box. Whoa! Almost missed that one. Yeah, should be straight lines. Wow, should have a nicer box. Yeah. Okay, so now that we have the diagonals, we need to identify which one has the minus. The x has the minus, so it opens away from x. Okay. Yes, then it extends on and behaves to those asymptotes. To a more advanced example, here I'm getting shifty. I'm moving it around. It moves the opposite of the way you think it would. So here I move 2 in the right, and then 1 down. Okay, so now this is my new point where I'm going to go left and right and up and down from. Sure, I want to say it's the center, but it's not really a closed shape, so I think I would be goofy on that. He's goofy anyway. Okay, so this says 2 in the x direction from that point. 1, 2, there. 1, 2, there. This says 3 from the y direction, in the y direction from that point. This is 1, 2, 3, and 1, 2, 3, tee-hee, tee-hee. So now we make a box. Then we connect the diagonals of this box. Now we have to identify which one has the minus sign. The y has the minus sign, so it opens away from y. Yeah. Ready, 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 ready. Okay. Oh, wait. Down here, see, we want to put it in standard form. I see, I'm not shifty. So then, I'm going to have x over, x squared over. Okay. How far does it deviate from the center of that box? 2. So this is going to be 2 squared. And it opens away from y, so that gets the minus sign. So then it's y squared over, how far does it deviate there? 1, 2, 3, 4. Yes. 4 squared. That game you used to play when you were young. Finish him. X squared divided by 4 minus y squared divided by 16 is 1. Fun. You're done. Last box of the day. But this one has a flat